Machine learning, it can feel like some kind of magic. But today, we're going to pull back the curtain and peek inside the black box. We are going to break down this amazing technology into simple, easy to understand steps to show you how a machine actually learns. I mean, really think about it. Your phone just knows a face in a photo, or a chatbot seems to get exactly what you're asking. It feels like wizardry, doesn't it? But here's the secret. It's not magic at all. It's a completely logical process that, I promise, by the end of this, you'll totally get. And to make this all feel really concrete, we're going to use one simple analogy through this whole thing: training a puppy. Because, just like a puppy, a machine learns from experience, from feedback, and a whole lot of repetition. This metaphor is going to be our guide. Okay, so here's our game plan. First, we're going to talk about the building blocks, which is all about data. Then we'll dive into the training manual, the learning part. After that, it's graduation day, where the machine makes predictions. And finally, we'll tie it all together and see why any of this really matters. So, where does any of this learning actually begin? Well, before you can learn anything, you need something to learn from, right? For a puppy, that's every sight, every sound, every smell. For a machine learning model, it's data. And believe me, it needs a lot of it. And this right here, this is the golden rule of machine learning. You have to get this right. It basically means that if the data you start with is messy or inaccurate or biased, then your results will be too. It's the old saying, garbage in, garbage out. This foundation, the data, determines absolutely everything that comes next. Now, this data usually comes in two main flavors. On one side, you've got labeled data. That's where we've already gone through and tagged everything with the right answer. Think of it like pointing to a toy and telling our puppy, this is a ball. Super clear, right? But then you've got unlabeled data, which is just a pile of raw information with no answers. That's like letting the puppy just wander into a room full of toys to try and figure things out on its own. Data also comes in different shapes and sizes. You have structured data, which is all clean and organized, fitting perfectly into spreadsheets with neat rows and columns. Imagine a list of every single toy the puppy owns with its type and color all laid out. Easy. But then there's unstructured data, and that's the opposite. It's messy, it's chaotic, it has no set format. We're talking about a jumble of photos, random paragraphs from a book, or just a messy pile of toys on the floor. All right, so we've gathered all our data. Now it is time for the main event, the actual learning process. This is where we pick a training manual, what we call an algorithm, to teach our model how to make sense of everything we just gave it. In this learning process, it pretty much follows one of three main paths. You can think of them as different teaching styles for our puppy. There's supervised learning, unsupervised learning, and reinforcement learning. Let's break down what each of these really means. First up, supervised learning. This one is the most straightforward. We use that neat labeled data and basically show the model, hey, when you see this input, you need to produce this output. It is exactly like teaching your puppy to sit. You give the command, sit. That's the input, and you guide it until it does the right thing. That's the output. And you just do it over and over and over again until it gets it right all by itself. Unsupervised learning, on the other hand, is all about discovery. Here, we hand the model that messy, unlabeled data and just ask it to find interesting patterns or groups on its own. We don't give it any answers. It's like watching our puppy. With no help from us, just start sorting its toys into two piles. The soft, cuddly ones go here, and the hard, squeaky ones go over there. It found a pattern we never even told it to look for. Kind of cool, right? And finally, we've got reinforcement learning. This one is all about learning from feedback, pure trial and error. The model tries an action, and depending on the outcome, it gets a reward for doing something good or a penalty for doing something bad. Think about a puppy learning what it's allowed to chew on. When it chews its toy, you say, good boy, that's a reward. When it starts gnawing on your shoe, you go, no, that's a penalty. Over time, it just learns to do more of the stuff that gets it rewards. So after all that training, all the data, all the learning, our model is finally ready to graduate. It's time for it to apply everything it's learned to brand new situations it's never seen before. In the world of machine learning, this whole process of making predictions on new data, we call that inferencing. And a trained model can make these predictions in two main ways. First, there's batch inferencing. That's where we process a massive amount of data all at once, like analyzing a company's entire sales data for the last quarter. But then there's real-time inferencing, which is all about making split-second decisions on new data as it comes in, just like a self-driving car having to brake instantly for an obstacle. Okay, so we've got our data, we've done our training, and we're making predictions. But the big question is, why does any of this actually matter? Well, let's connect all these dots back to the technology that you're probably using every single day. And that's really the key takeaway here. This simple but powerful process is the engine running under the hood of so much of our modern world. From a chatbot understanding your question to a self-driving car navigating a busy street, it all boils down to these exact same steps. You start with data, you use an algorithm to learn from it, and then you use that trained model to make smart predictions. You see, by understanding this process, we get to move past this idea of machine learning being some kind of incomprehensible magic. We can see it for what it is, a tool, a very powerful tool, for sure, but one that we build and we guide. And that lets us start asking the much more important questions, not about how it works, but about what we want to do with it. We've taught the machine to learn. The real question is, what should we teach it next?